Welcome. Today we will be going through a problem adapted from question 5 of the Hamilton Olympiad 2008. In the diagram shown, we have two congruent squares, ABCD and AEFG, with a common vertex and an overlap. P is the intersection of DC and EF. What is the area of the purple if DP equals 3 and PF equals 2? Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. Split the purple shape into two right-angled triangles. Hint number 2. Use Pythagoras. Hint number 3. Write two expressions describing AP, both in terms of the side length of the square. Solution. Let the side length of the square be x. Then using Pythagoras' theorem on triangle ADP, AP squared equals x squared plus 3 squared. Using Pythagoras' theorem on triangle AEP, AP squared equals x squared plus x minus 2 squared. AP squared equals x squared plus 3 squared equals x squared plus x minus 2 squared. So 9 equals x squared minus 4x plus 4, which gives x squared minus 4x minus 5 equals 0, and x plus 1 multiplied by x minus 5 is 0. Since x cannot be negative, x equals 5. Then the area of the purple is 5 multiplied by 3 multiplied by a half, that's the area of triangle ADP, plus 5 multiplied by 3, that's 5 minus 2, multiplied by a half, which is the area of the triangle AEP, which gives 5 multiplied by 3, which is 15. Thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. Goodbye.